Okay, hello Ibarquans. Today I'm going to solve 100 and 334 problem. We have to find the city with the smallest number of neighbors at the threshold distance. What we have to find? We have to find the city with the smallest access to the neighbor's city. How we can do it? First, for example, we have four cities, and for example, city 0 have to access for city 1 and for city 2, but why we haven't access for the city 3? Because the distance between them 0 and 3 is higher than threshold. Our threshold is 4. For example, for each example is it's another, and for this problem it's 4, and because it's higher than threshold, we cannot apply this distance count. That's why city 0 have only access to the city 1 and the city 2. Also, the city 1 have access to 0, 3, and the city 2. Why? Because he has the directly access to the cities, and it doesn't higher than threshold. That's why we cannot. That's why this. Let's move the next city, and the city 2 also have directly access to the city 3 and 1, and bi-dimensional access to the city 0, and it doesn't higher than threshold. And the city 3 also have access only to the city 1 and 2. How we can do it? First, we use the algorithm of Floyd-Warshall's algorithm. And how we can do it? First, we have the city 0, 1, 2, 3, and 3, 1, 1, 4. We have the directly access to the city 1. Okay, cities, city 0, 1, 2, and 3. City 0 have access to the city 1, 2, and we cannot count 3 because the distance higher than threshold. We said it before. And the city 1 have access to the 0, 2, 3, and the city 2 have access directly to city 1, 0, and 3, and the third city have only access to the city 2 and 1. What we do is we have the same answer but another city. We have to find the city with the biggest number, with bigger number, and that's why the answer is 3. And we use Floyd-Warshall's form algorithm. Sorry for my not accurately table. I am trying. 0, 2, 3. It's our cities, and we are going to use Floyd-Warshall's code algorithm. The city, we don't count this column. Okay, distance between from 0 to 1, it's distance 3. Second, it's 4. It's 5 because 3 plus 1 plus 1 it's 5. From city 3 to from to 1 it's 1, and from 2 it's 2. Okay, it's our from directly to it's 4. From 3 it's from 2 it's another, and from 2 it's 1. It's exactly the same. From 0 to 1 it's this between distance it's 5, 4, and the city from 0 to it's 1. Okay, we count we solve this, and it's bigger than threshold. It's bigger than threshold, and we have to count only these cities that don't have the threshold. This these ones, and these ones. Only the city 0 and the 3 is countable. Okay, first of all, we have to create integer array, two-dimensional arrays, and we have to create distance new integer, new integer with the highest n, and then we have to initialize I is 0, I less than n, why n? Because it's a city, there is 1. Okay, I plus plus, and what we do, we fill arrays fill distance between distance I, and we represent in this city infinity, one unreachable number, because in Java there is no infinity. Why and it's infinity? Because when we stay in the city 0, for example, the city 2 and the city 3 is unreachable, the infinity, and the 1 we have the direct access. That's why the distance between them 3. And in this situation, to write this unreachable statement, we write this number. And the distance, like from city 0 to get city 0, its distance between it's 0. I mean, how we can get to city 0 from city 0? It's not 0. From, and for city 1 to get city 1, it's also 0. Okay, distance ij, it's 0. And what we do, we have to set weights, its edges. How we do? We create for each operators edges distance edge 0, edge also, it's edge is the third element, but by index it's 2. So we're copying this. Okay, we set edges. After that, we have to apply the Floyd-Warshaws algorithm for int k. It's 0, k is less than n, and it's a city, and we k plus plus for int I is equal to 0, I less than n, and I is incrementing for is int equal to j is 0, j less than cities, j also incrementing, and the distance between them, distance I mean j equal to, we have to find the minimal element, distance I j between distance plus I and k plus distance k and j, k and j, k and j. Apply. After that, what we do, and we have to count the reachable cities. First of all, we create answer that's equal to -1, and we have to create the mini our integer. It's our max value, of course. To find the minimal element, first of all we have to start at the maximum element. For int and of course we have to create the reachable cities array. Int reachable cities, the size of n, it's our cities, and then I equal to 0, I less than n, I plus plus. We have to count, int count, it count equal to 0, and what we have to find out, integer j equal to 0, j less than cities, and the j is incrementing. What we do next, and we have to don't count the zeros, when city at the staying when this position. I don't equal to j, and distance I j less than threshold. Yes, distance less than threshold, and what we do after that, yes, if it's we counting the city, no mistake, and after that we have to set new we have to update our elements. Reachable I is equal to count. If our count less than and equal to mini, we have to create set mini equal to count. That's it, and the answers are equal to I, and we have to return that answer. Let's run. Okay, let's submit, and that's it. Okay, thank you, Barkhonish. Goodbye.